Hey guys, Andre Freeman here. All right, let's work through an example involving the empirical rule and properties of bell-shaped distributions or normally distributed populations. This example relates to the weights of grapefruits grown on a farm. It says that the weights of these grapefruits are normally distributed with a mean of 16 ounces and a standard deviation of 3.8 ounces. So those are the population parameters. And we can use those values to determine intervals containing specific percentages of the weights of the grapefruits in this distribution. So let's look at this. We're going to begin by writing the positions. We're writing values on those horizontal axes corresponding to specific positions. The mean of the distribution is in the center. We're told that the mean is 16 ounces. And then we're going to add one standard deviation to 16 to get the next position. So 16 plus 3.8 would be 19.8. We add 3.8 again, we get 23.6. Add 3.8 again, we get 27.4. So let's see what we have. 16, that is the mean, mu. We added one standard deviation to get 19.8. So 19.8 is mu plus sigma, the mean plus one standard deviation. We added two standard deviations to get 23.6. So 23.6 is the mean plus two standard deviations. We added three standard deviations to get 27.4. So 27.4 is the mean plus three standard deviations. So we've indicated the mean and the positions that are 1, 2, 3 standard deviations to the right. Let's now find the positions that are 1, 2, 3 standard deviations to the left. So we subtract now 16 minus 3.8 to get 12.2, minus 3.8 to get 8.4, and minus 3.8 to get 4.6. 12.2, that's the mean minus one standard deviation. That's mu minus sigma. 8.4, that's the mean minus two standard deviations. Mu minus two sigma. And 4.6 is the mean minus three standard deviations. What we can now do is use the empirical rule. So the empirical rule states that the middle 68% of any normal distribution is within the mean minus one standard deviation and the mean plus one standard deviation. So what we're saying in this case, in this specific distribution, going from 12.2 to 19.8, in this interval, we have 68% of the data values. In this case, that's going to be the grapefruit weights. So 68% of the grapefruit weights are going to be between 12.2 and 19.8 ounces. We go two standard deviations below, that's 8.4. Let's draw a line there. And then 23.6, that's two standard deviations above. So now within this interval here, from 8.4 to 23.6, that interval contains the middle 95%. So 95% of the grapefruit weights are between 8.4 and 23.6 ounces. And if we go out further, this position is three standard deviations below the mean. This position is three standard deviations above the mean. So between 4.6 and 27.4 ounces is the middle 99.7%. So 0.997, that's 99.7%. So virtually all of the grapefruit weights in this distribution, this population of grapefruit weights, are between 4.6 ounces and 27.4 ounces. The next thing that we can do, which is really important, is we can basically break these intervals into smaller intervals and determine the percentages in those smaller intervals. So if I break this one in half, if there's 68% going from 12.2 to 19.8, because this is a symmetric bell-shaped distribution, the area or the percentage from 12.2 to 16 should be the same. as from 16 to 19.8. So if we break 68% in half, we get 34%. So 34% of the grapefruit weights are between 12.2 and 16 ounces, and 34% of the grapefruit weights are between 16 and 19.8 ounces. So collectively, going from 12.2 to 19.8, within that interval would be 68%. So let's do some math to figure out the rest of these. If we subtract 95 minus 68, we get 27. Let's show that. So 0.95 minus 0.68, that's a 5 there, we get 0.27. So 27% corresponds to the percentage in this interval and in this interval together. So if we separate this into two parts, we divide by 2, we get 0.135. So 0.135 or 13.5% is the percentage of values in this subinterval, and 0.135, 13.5% is the percentage of values in this interval. If you add up all 4 of these percentages, you get 0.95. Let's do the same thing now to get these two percentages. We'll subtract these values now, because going from 4.6 to 27.4, that interval of values contains 99.7%, but from 8.4 to 23.6 contains 95%. So we can use the difference to get the percentages in these two subintervals. Let's do the math. So we have 0.997 minus 0.95. We get a difference of 0.047, which is 4.7%. That is the percentage, the sum of the percentages in both of these. Well, if we divide that into 2 equal parts, we get 0.0235. So this subinterval contains 0.0235, or 2.35%, and this subinterval contains 0.0235, or again, 2.35%. The sum of all of these orange percentages will give us 0.997. But 100% of the distribution is represented by this model. So we don't want to lose anything. So to get the percentages in these tiny tails here, we have to figure out, what are we missing? Well, 1 minus 0.997 is 0.003. And if we break that in half, we get 0.0015. So this last subinterval contains 0.0015, or that would be 0.15% of the values. And this interval, meaning values, weights greater than 27.4, contains 0.0015, or again, 0.15%. Just let's interpret this real quickly. This is saying that 0.15%, let's just get this out the way here. This is the math we did. This is 0.15%. The percentage for the values greater than 27.4 ounces. In other words, the probability or the percentage of grapefruit weights that are more than 27.4 ounces is only 0.15%, which is very small. Okay, so we basically have done this analysis to actually answer part 2. So just to recap, the middle 68% of weights go from 12.2 to 19.8. The middle 95% of weights go from 8.4 to 23.6. And the middle 99.7% of weights go from 4.6 to 27.4. We found these additional percentages in orange to answer the questions below. So it says now, part 2, what percentage of grapefruit weights are between 8.4 and 19.8 ounces? Well, 8.4 is here, 19.8 is here, so we have to find the percentage corresponding to the values between 8.4 and 19.8. That would be 0.135 plus 0.34 plus 0.34, because these 3 percentages correspond to weights between 8.4 and 19.8. So we add them together. So we have 0.135 plus 0.34 plus 0.34. We get 0.815. This is the same as saying 81.5%. So 81.5% of grapefruit weights are between 8.4 and 19.8. We added up those three percentages. What percentage of grapefruit weights are less than 12.2 ounces? Well, this interval, and this interval, corresponding to these three percentages, represent values that are less than 12.2 ounces. So we're going to add up 0.135, 0.0235, and 0.0015. Again, those are the percentages corresponding to the intervals of values less than 12.2. So we have 0.135 plus 0.0235 plus 0.0015. When you add these together, you get 0.16, which is 16%. So 16% of the grapefruit weights are less than 12.2 ounces. Lastly, what percentage of grapefruit weights are greater than 23.6 ounces? Well, 23.6 is right here, and there are two subintervals with values greater than 23.6 ounces. This one here and this one here. And there are two percentages that correspond to those intervals. So the percentage of grapefruit values greater than 23.6 ounces will be the sum of 0.0235 plus 0.0015. You see, we're always adding up the percentages corresponding to intervals of interest. So 0.0235 plus 0.0015. When we add these together, we get 0.025, which is 2.5%. So three separate answers. And if we talk real quickly about this last one, only 2.5%, right, 2.5% of grapefruit weights are greater than 23.6 ounces. So you can see how most of the grapefruit weights are less than 23.6 ounces. This value is somewhat extreme or unusual. 16% of grapefruit weights are less than 12.2 ounces. So 12.2 is not unusual. And then lastly, 81.5% of grapefruit weights are between 8.4 and 19.8 ounces. All right, guys, I hope this helps.